In the first part of this experiment, I'm going to show you how to prepare a sample of benzoic acid by the hydrolysis of ethyl benzoate. We'll then go on to purify the sample, and in the second part of this experiment we'll look at how we can identify our product. Right, so to start we're going to measure approximately 5 grams of our ester ethyl benzoate. So put a cork ring and a 100 cubic centimetre round bottom flask onto the balance, tare it, and then I've measured out 5 mils of the ethyl benzoate, and that will be roughly 5 grams, but we'll measure exactly what it is. Carefully add it using the funnel. Make sure you don't get any drips on the pan, and that's 5.41 grams. Right, so the next thing I want to do is hydrolyze the ester in order to make our benzoic acid. So we're going to use sodium hydroxide as a catalyst. So I'm going to add approximately 50 cubic centimetres of sodium hydroxide. In fact, I'll use I'll just pour it in carefully. Okay. I was going to suggest using the funnel for that, but that actually would have introduced a little bit more of the ester, so that wouldn't have been correct. Okay, so we're now going to heat it up. So we'll add a few anti-bumping granules, and we're going to heat it up in order to speed up the hydrolysis of the ester. The problem is, however, the ester is really volatile, and so if we heat it up in an open beaker, the ester will evaporate before it actually hydrolyzes. If we seal the beaker, then it will explode as the ester vapour builds up. So to get around that problem, what we're going to do is reflux the mixture. So this is the apparatus over here. So we put our reaction mixture down here. We're going to heat it gently. The ester will evaporate, but as it goes up into this condenser, which will be cooled with running cold water, hopefully it will condense before it comes out the top. So it will condense and drip back down into the reaction mixture. And as long as we don't heat it too vigorously, the loss of ester to evaporation should be very small. So we'll lower the condenser so it fits into the round bottom flask snugly. Okay. Then we want to get the cold water running through the condenser, so put the water in from the bottom, and we don't need a very fast flow of water. It's constant flow of water. And then just turn on the heat, and we want to bring it to a gentle boil, and then we leave it for 45 minutes to an hour till all the ester has disappeared, so there's no oily film on the top of the reaction mixture. So the ester is refluxing away quite nicely at the moment, so it's bubbling away quite gently, and you can see the ester condensing in the condenser, but most of the condensation is happening in the bottom half of the condenser. There's not so much in the top half of the condenser, and that gives you hope that very little of the ester is actually being lost. It hasn't been going for very long, and if you look at the reaction mixture, you can see there's still oily drops of the ester on top of the aqueous solution, so it shows that we've still got quite a long way to go to hydrolyze all the ester. In the meantime, of course, you could now be working out what the theoretical yield of the benzoic acid should be. So what's happening in here at the moment is that our ester, our ethyl benzoate, has been hydrolyzed with the sodium hydroxide. So when we hydrolyze an ester, of course, break this bond here and make the acid, benzoic acid, and the alcohol, ethanol. But because it's sodium hydroxide we're using as the catalyst, the sodium hydroxide will then react with the benzoic acid to produce the sodium salt of the carboxylic acid. So we're producing sodium benzoate, and ethanol is the other product. So when this has been refluxing for about 45 minutes to an hour, we should have hydrolyzed most of the ester and produced sodium benzoate. The clever bit, as always, is then getting the sodium benzoate out of the solution, turning it into benzoic acid, and then purifying it, and then actually trying to prove that we've actually got benzoic acid by a series of tests, melting points, thin layer chromatography, etc. So I've left the sample for about an hour, and as you can hopefully see, there's no sign of any oily residue on the surface of the reaction mixture. So I'm now going to turn off the heating mantle and leave the reaction mixture to cool down. Our reaction mixture has now cooled down, and I'm going to transfer it to this 250ml beaker. And I'm going to leave the anti-bumping granules in the reaction mixture. So I've left the anti-bumping granules in there. We're now going to precipitate out the benzoic acid by adding approximately 30 cubic centimetres of hydrochloric acid, and this will react with the sodium benzoate to produce benzoic acid, which should appear as a white precipitate. So if we give it a bit of a stir, start adding our HCl. Unfortunately, we're getting a nice white precipitate produced, which will be our benzoic acid. Give it a good stir round. Plenty of benzoic acid there. We want to check that we've added enough HCl by checking that the solution is now acidic. So if I take a little drop and put it on here, well, hopefully you can see the red colour. Okay, hopefully you can see the red colour there. Okay, so the solution is now acidic. We've precipitated out our benzoic acid, and the next stage is to separate the benzoic acid from the reaction mixture by filtration. So we put the buchner funnel in the buchner flask, turn the tap on, make sure we've got a bit of suction here in our buchner flask, and then we start adding our reaction mixture. Probably need to use the glass rod to try and scrape out some of the precipitate. So there's quite a lot of the benzoic acid left in the beaker here, so we'll wash it down with a little bit of water to try and reduce our transfer losses. Do that one more again. and I think I'll give it one more wash out. Now it's not like volumetric analysis where you're almost guaranteed getting essentially 100% transfer. There will be a little bit of benzoic acid lost in this process, so when you're explaining why you didn't get 100% yield, the transfer losses is a relevant reason. Okay, so we'll just let that filtration finish, and that's us got a good pile of our crude benzoic acid, and the next stage of the process is going to be purifying that benzoic acid. I've transferred the crude benzoic acid into a clean 250 cubic centimetre beaker. Once again, there will be transfer losses in this process, as it's very hard to get all of the benzoic acid out of the buchner funnel. So what I want to do now is to purify this by recrystallization. So to purify something by recrystallization, the important thing is choosing the correct solvent. You want the benzoic acid to be insoluble in the cold solvent, but very soluble in the hot solvent. And by hot solvent here, I think I'd say about 60 to 70 degrees, because if you go above that temperature, then when you start to try and filter the sample, it immediately cools down and starts to precipitate out if you go too high. So we're going to work about 60 to 70 degrees. And to that end, I've already put the buchner flask and buchner funnel in an oven at 70 degrees to heat them up to that temperature. Now the solvent, which is very convenient in this case, is going to be water. So I'm going to add 100 cubic centimetres of water to my benzoic acid. I'll give it a little stir, but not a lot's going to happen, because the benzoic acid is insoluble in water at room temperature. However, if I heat it up to about 60 to 70 degrees, all the benzoic acid that's in that sample should dissolve in the water. Anything that hasn't dissolved at 70 degrees will be impurities, and we want to filter them off. So while the buchner flask and buchner funnel heat up to 70 degrees in the oven, we're going to put this on a hot plate and heat it up. I said to no more, 70 degrees will be the maximum temperature we go to, stirring it quite a lot, and we'll see what it looks like once we've got it up to that temperature. So I've just gone just above 70, and most of the benzoic acid has now dissolved. You'll see that around the edges is some benzoic acid that is above the waterline. So to bring the temperature back down to 70 and to give that a chance to dissolve, I'll just wash around the edge of the beaker with some more water. So I'll get my temperature back down to 70 and gives that a chance to dissolve. So I'll give that a couple more minutes, and then we'll take the buchner funnel and the flask out of the oven, which will be about the same temperature, about 70 degrees. Might be quite hot to touch, so just be a wee bit careful. And then we'll quickly filter it so that the water does not cool down too much, and the benzoic acid start precipitating out. So we'll quickly filter it, transfer the filtrate into another clean flask, and wait for it to recrystallize. Okay. So having added that extra water, I've ended up with between 150 and 200 mils of water in here, and it's just between 70 and 75 degrees. And despite what I said earlier, maybe just having that few degrees above 70 gives you a wee bit of leeway. So anything that's not dissolved now is likely to be an impurity. So I'm going to get my hot buchner flask and buchner funnel out of the oven, very quickly set up the apparatus for filtration and filter this, discarding the impurities that are the residue on the filter paper, and then quickly transferring the filtrate into a clean 250ml beaker where it will cool down and the benzoic acid will recrystallize. So there's my buchner funnel, buchner flask, a hot buchner funnel, filter paper in, attach up the water pipe, turn the water on, and then let's start filtering. Everything's a wee bit hot, so you do have to be careful. Yep, applying a bit of downward pressure just to get a good vacuum. Keep on topping it up. Put the 250ml beaker back on the hot plate when you're not using it. To keep it warm, stop it cooling down. Okay, it's filtering quite nicely. That's the last batch in. We'll wait till that's filtered through, then we'll quickly transfer it into this beaker. Okay, so transfer it into this beaker, and as it cools down, which it's already doing, we'll start to see the benzoic acid, the hopefully pure benzoic acid, precipitate out. So we're going to leave that for 5 or 10 minutes till it's cooled down to nearly room temperature and all the pure benzoic acid has crystallized out. So by now the mixture is about room temperature, and you can see that the benzoic acid, the pure benzoic acid, has now recrystallized. So we now do a rather more relaxed filtration. So turn on the water and we'll filter off our pure benzoic acid. There's an awful lot left in the beaker, so we shall wash that out with water, because remember the benzoic acid isn't going to dissolve in cold water. Wash it out again, and one more time for luck. Again, it's not volumetric analysis. You will lose a bit of benzoic acid in these transfers, but we're more interested in getting pure benzoic acid than getting a huge amount of benzoic acid. Okay, so now in the buchner funnel here, I've got pure crystals of benzoic acid. Some of the insoluble products had been removed from the initial filtration, and then some of the impurities that were more soluble in benzoic acid and are soluble in cold water have been lost in the filtrate. So up here I should have nice pure benzoic acid. So the last thing to do for this stage is to, using a spatula, transfer the benzoic acid crystals onto a pre-weighed watch glass. So I've already weighed and recorded the weight of this. So put the benzoic acid crystals on here, stick it into an oven for an hour at 70 degrees, and then take it out, reweigh it, and you'll get your mass of benzoic acid, and you can work out the percentage yield for your process. Thereafter, in the next video, we'll talk about the tests we can do to prove that what we've got here, the white crystals in here, are indeed benzoic acid and not something completely different. The crystals have been dried in an oven for about an hour, and I've taken them out and reweighed them, and I've got a value of 24.38 grams. So from that I can work out my mass of benzoic acid and hence the percentage yield for the procedure. Note that we haven't bothered drying it to constant mass in this situation. We're not doing a quantitative determination, and any water left after an hour dry will be so small that it's relatively insignificant. 1 mole of ethyl benzoate produces 1 mole of of benzoic acid. So if my mass of ethyl benzoate is 5.41 grams, I can work out the number of moles I've got of ethyl benzoate, which will equal the number of moles of benzoic acid. And so my mass of benzoic acid will equal the number of moles times the GFM of benzoic acid. And in my case, I've got 0.0361 moles of benzoic acid should be produced. Gram for a mass of 122. So I should have produced 4.40 grams, in fact 4.40 grams of benzoic acid. In reality, I've produced 2.28 grams, so my percentage yield is my actual yield, which is 2.28, divided by my theoretical yield, which is 4.40, times 100, which means my percentage yield was 51.8%, which is pretty good really for this procedure. Why is it less than 100%? Well, lots of reasons. Transfer losses accounted for quite a lot. Also, the initial refluxing may not have gone to completion. And also maybe we lost some of the benzoic acid dissolved in the water. So there's lots of places where we could sensibly have lost the remainder of our yield. But for organic synthesis, a yield over 50% is actually not too bad. So that's the end of the first part of the experiment. And in the next video, we will look at the second half, where we carry out certain experiments to determine that the substance we produced is benzoic acid.